So I think when we left, we were talking about the autopilot software architecture. So
Correct.
if I want to divide, or maybe whole architecture, we can divide into three parts. One is like RTOS. So already we have discussed about two parts like GPOs and NUTX. There could be other option like FreeRTOS or Jaifer. Then middleware. So most of us use publish subscribe either by URB or mini rows or something RTPS. And then application layer where we have our whole program like attitude control, position control, estimator, navigator, commander. So I have not seen the Ardu pilot code, but I believe it would be similar there.
Yes, correct.
Huh?
Apart from the they do not rely on the publisher subscriber method. So they have kind of they have CBOS on the background, and on top of that they write hardware drivers, and then they have the application layer which interacts with the hardware drivers.
So it directly interacts with hardware layer.
Yes, correct. Yes, correct.
So then do it has a work queue, or how it does, because where data get stored, because when it comes from the sensor, somewhere it has to be stored, right? And that
correct. So they kind of have memory allocation on the system. For that, for a particular thread, they have memory allocation on the system, and generally microcontrollers have a large amount of memory, not in terms of, I'm not comparing it with the onboard computer system, but they have enough amount of memory so that they can handle basically the threads, the amount of space which you have provided.
And then the scheduling policy is similar. They are round robin, or maybe priority or preempting in
priority. It is based on the priority.
So yes. I think priority with round robin, I guess, because you might have.
Yes.
Okay. So now I think since we should thank the open source community. So where were we? Okay, we were talking about architecture. So I think thanks to this open source community that at least whoever in the drone business, they are aware of, and they have a understanding how these things work if they are bit into the autopilot development, how RTOS, middleware, and application. But if I see now as a product wise, because if I have to do the research, or maybe I have to demonstrate some things, I will take it and implement the idea. But now when I have to develop the product for quadrotor, let's talk about quadrotor. There are two main concerns from my side. One is like everyone wants maximum endurance.
Correct.
Okay, and therefore we also started our startup like Tell Endure, right?
Correct.
So maximum endurance. Now, if you see the motor and propeller data is already kind of optimized, and everyone know which one will give the best. So we want the minimum weight frame. Second issue is that, see, the second, or maybe I add one more. Second issue is that we have to calibrate our sensors, flights. So that we were used to, and I think when I talk to the off record to you, you talk about that. You can again discuss. And third one is about ground stations. So can you talk about that?
Okay, so each part is very important, and I think the first question is the most important for each and every startup. That if the motor propeller are same, if everything is same, everybody is using PICSOC, let's say, then what is making the difference? Why there is a difference of huge flight time, like somebody is getting 20 minutes, somebody is getting 50 minutes. So this is the most important question, and the answer to this question is not very straightforward. The answer to this question, all I can say is, one who finds the answer to this question actually wins the game. But for simple perspective, what I can say is most of the people think like that you do have PICSOC, you do have motor, you do have propeller. If I can make a frame within very less weight, I am all done for. I am all done for, and I would get the maximum endurance out of it. But that is not the thing. Each and every wire you put into your quadrotor, the way you design your quadrotor, the way you design your electronics based on minimizing the footprint, based on minimizing the wire, you would be getting. So these all things are important. For example, if let's say if you are putting a wire gauge of 22, and if you kind of get your quad rotor working on the same wire gauge, on the wire gauge of let's say 25 or 26, then there is a difference of about 10 to 20 grams, and it could play a huge role in improving your endurance. So that is kind of one of the example where you start thinking about product designing, where you start thinking about how to minimize each and everything, not just about motor and propeller.
So I think
People usually
apart from the aerodynamics
Yes.
efficiency,
Yes,
aerodynamics efficiency we can determine from the motor and propeller set.
Yes.
Now the skills comes like, say you have a lot of like onboard things.
Correct.
So
Correct.
I believe for autopilot, like most of us, we are using STM32, either F4 or F7. And
Yes.
if we use this F Pixop, we do not have a control on sensors also. So now,
Yes.
how do we do the like product optimization? I don't say like the for optimization. Like
Correct.
for example, your frame weight is 150, but many people are using carbon fiber also, right? So they will get similar weight class. But now the game is for each gram, right?
Yes, the game is for each and every gram. Correct. And at the same time, you also think about the user on the user's perspective. So it should be very simple for user, because when you are using it and when user are using it, they are completely different thing. User is going to handle it very roughly. The places, the atmosphere where they are going to fly is going to be very rough, and you should have that field experience as well, and you should have the flying experience as well. Fly your drones as much as possible, and to understand that what problems may come, and then try to solve those problems without increasing a lot of weight.
Okay. So
now your second question is basically of the sensor calibration. So usually sensor calibration require once for accelerometer. Gyros are calibrated after each and every startup. So
these are auto calibrated, or you have to calibrate manually?
So accelerometer, once we have to calibrate manually for it to give the 360 on all the 6 directions. Basically, you need to have the gravity vector for it to understand the matrix for calibration. And the most important calibration which needs to be calibrated again and again is the magnetometer, and that too if you are moving about 100 kilometers or so. Because as you move about 100 kilometers, the direction of the north is going to change, because your north pole direction is going to change. So magnetometer calibrations are generally required, else there is not much to be calibrated apart from magnetometer. So I would like to add that people are working on removing that magnetometer calibration as well. People are working on dual heading systems. There are no particular dual heading systems, and if you are interested in working dual heading systems, that is a great opportunity, because there is no such kind of module available for dual heading systems.
So when you say gyros, so what when it is stationary, does it only calibrate the bias or what, and then store it? Right?
So it once calibrate the initial offset, assuming that the frame is static. So during the initialization phase, it will just calculate the offset, and it will constantly subtract those offsets from the gyro values.
So that happens automatically, right?
That happens automatically.
And for accelerometer,
for accelerometer, there is a calibration matrix which will be computed once when you do the manual accelerometer calibration on all the 6 directions, and it will remain into effect for all the flights.
So what is lifetime for this calibration?
So accelerometer calibration, gravity doesn't change over the earth, so you can have a number of times. I have not calibrated accelerometer after doing it manually for once.
So, but in my experience, when we have used PX4, we have to frequently calibrate. So it is a feature of the
RD
pilot.
So?
Yes.
It might be so, because I don't think accelerometer calibration will require any.
Because the reason is these are MEMS sensors.
Correct. That is true. That is true. But I haven't seen this with the RD pilot case, because both of them are using the same hardware. They are using Pixop.
Okay. So magnetometer, now ground station. Okay. So another feature, because it's user would interact through the ground station, right?
Correct. I don't know how many of the people who will be watching this have seen the DJI interface. So the GCS interface for the user should be as simple as possible and not as complicated as the mission planner which people generally use, or the QGround control which people use. So the thing is that user should not have access to more than, let's say, 3 to 4 buttons. Only these 3 to 4 buttons will help him do his mission or his task. It should be as simple as that. So designing your GCS becomes one of the tasks when you are supplying something to the user. And people can start by looking into QGround control, because QGround control or mission planner, but I would suggest you to move towards QGround control because it is based on Q, and it is quite easy to understand. You can work towards it, and you can also develop some softwares of your own on Q.
So, so then see, when you say that it's 3-4 buttons, so one is like choosing the missions, waypoints,
Yes, correct.
takeoff and landing. Maybe if you have some payload, you recording, or I don't know what else feature do you give then.
So generally for the mapping, for the surveying area, I would say that you generally select an area on the map, and it will automatically create the path for user, and the user generally have an upload button to upload it onto your drone, and then just say take off, and then that's it.
That would make the life convenient for users, right?
Yes, and it would make it convenient for you as well, because you are going to train them and they should feel comfortable about it.
So I think with this kind of we have uh, concluded technical part. Now coming back to, because see, I think you are here for almost more than 2 years, and like when I say here means with CD Space, your startup, and with this 2 years, 8 or 9 months is like Corona period. Okay.
Yes,
And
6 to 7, I would say. Yes.
So it started in March in India. So financially, how difficult it was, and how difficult are you finding that?
Yes, it is quite difficult. I would say it is not that easy. And as you know, the drone space requires a large amount of money as compared to the software space. In software space, it is easier for you without money, but in hardware you cannot, because lot R&D requires a lot of money. So it has been difficult, but since we kind of have the knowledge, and we also kind of pivoted towards some smaller projects so that we can earn money and fund our R&D. So as I already told you, that we believe that it is a survival game, and eventually it is going to happen some or the other time. For example, the drone market is currently opening in India. A lot of company died 2 years ago, but if they have sustained over this time, so they would have seen an open market. Large amount of tenders are coming into picture in terms of police, as well as in terms of enterprise solution like mapping and all. So yes, there is hope, and it is also difficult. I wouldn't say it is very easy.
And I think because I know personally you and maybe your team. So feature is that, see, you have managed your startup with the 3 guys only, I believe.
Correct.
But see, it's a kind of blessing that you all are like you have you can jack of many things, or maybe masters of many things. I don't say should say jack of. You all are masters of many things. Then it would be like, for see, if someone is entering, he has only 1 or 2 skills. Okay.
Correct.
So then it would be become difficult, right? Because I see when you work with me, I know that you do you fly also? Just I wanted to ask.
Yes.
So you know the programming, you made a frame, you know flying, you know the coding.
Correct.
So, and it's not only knowing, you have a in-depth knowledge. So people just knowing one skill or another and want to get into this, how could it be difficult for them?
So I can give you my example. It is as you told that I had a lot of experience, but it is not that quite true, because I did not have exposure to embedded side. I never made a PCB on my own before I started this startup. I never did an embedded programming. I never worked on the PX4 code or the Arduino Pilot code. I have just seen them. I have not changed a single thing on them. I usually worked on ROS, and before that I worked on Arduino. Arduino is quite a simple platform, as all of all the people who might be seeing this know. And working on ROS is completely different because it is on the onboard computer side. I kind of relied on the flight controller part. Everything I relied on Pixhawk or PX4, and I was working on ROS. So once I came into this industry, I knew that people do not want computer vision as of now. It is there, it is going to be there, but as of now, if you want to improve your performance, the things start from the most basic level. It starts
And,
from the
and especially it's true in the Indian context, right?
Yes, it is specifically true in Indian context.
No one wants this video now.
Yes, so in a startup, this is the most amazing thing that has happened to me, that my growth has been exponential. Each day you have to kind of fight for the survival. Each day you need to learn new things, and as you go ahead in your journey, you grow a lot. So I have learned quite a lot of skills, and I can say that yes, I have mastered some of these skills. And in a startup, you have to be jack of all trades and master of at least some. And as you start, you might not have that much experience, but if you think that you can do it, if you think that you can achieve something, and you can learn a lot of things on the way, then I think a startup is a very good way to learn a lot.
So maybe now we are in final section, because see,
Yes.
you are our alumni,
Yes.
K alumni, and you did. I don't know whether you did my course on not autonomous navigation, but I remember you did Gaurav Pandey's course that time, probabilistic robotics, and
Correct.
unfortunately now he is not there. So which type of course do you think should be there in academics that helps the, like maybe Make in India or Atmanirbhar Bharat, or it would be helpful for startup apart from the regular academic course?
Correct. So what I feel is there is a huge gap between what actually industry wants and what we are teaching our people in academics. So what I would say is, in the Indian context, context that people want an embedded hardware coder, embedded software, and embedded design. Nobody is teaching that over here. It is good that we are working on ML and AI for those of you who are planning to go for MS and want to go ahead for your graduation. But industry also wants people for embedded software and embedded hardware. And I usually we do hire interns, and I haven't seen a very good intern who has knowledge of all these things. So I think we should also focus on the embedded part. And also that part is also necessary, which the autonomous navigation part, and the course I did with Dr. Gaurav Pandey was also very useful for me. So if you are planning for MS, this is not going to be this is not going to work for you, because in MS, if you write that I have done embedded coding, I don't think it would make a good impression as compared to if you tell them that you are working on ML or AI. So yes, that's it.
Yeah, that's the two different things. See, but I believe even say you go abroad, see, hands-on experience no one can beat.
Correct, that is true.
So see, although you may not write that you have done the embedded programming, but when you say that you have made some new model, or you have made a model and fly it, so hands-on experience will be always useful.
Yes.
So you can learn the algorithm, can apply, and there are good tutorials are available, like for example ROS, or maybe it's deep learning or CNN. But you see that embedded, although maybe they are coding, but this you comes by experience or by implementing. It does not come. So it is in general true, but since you never know in hardware when you are working, it's not easy. You have to fix it and you have to get it tested, right? And it's test. So and that is not easy in compared to the like other things which are software based. So I think do you want to say anything else? Then otherwise we can conclude.
I think we can conclude. I think people who are thinking that that they have a fear of starting a startup, I would say that take a leap ahead, take a leap of faith, sorry, and have courage to do it, and do not give up. That's it.
So thank you very much for your time and revealing many things. See, people thinks keeps many things to them. Okay, so you have aspect, you talk about your journey, then your technical side, maybe financial constraint, and then how should one like go for that. So thank you very much, and I wish very good luck to you, and especially for your startup.
Thank you, sir.
Makes
Thank you
lot
so
of
much.
money. Thanks. Thanks a lot.
Thank you, sir. Thank you, sir. Thank you for inviting me again.